In today's video, we'll be learning about permutation for unidentical and identical objects in a circle, as well as solving problems in self-exercise 4.2. Okay, we start off with the permutation for unidentical objects in a circle. So unidentical objects, for example, is for human. Okay, or pupils or workers, yeah? So for n unidentical objects in a circle, the permutation is given by n factorial over n equals to n bracket n minus 1 whole thing factorial over n, and we can cancel out the n, and we get n minus 1 whole thing factorial. And we're going to use this formula to answer all the questions related to unidentical objects in a circle. Let's look at this example. Determine the number of ways to arrange 6 pupils to sit at a round table. So the keyword here is round. And it's pupils. So pupil is considered as unidentical objects, okay? And for this, the n is equals to 6. Yeah? So let's say this A, B, C, D, E, F. Okay? Student A, student B, student C, student D, student E, student F. They can sit in this way. So this is one way. Okay? Let's say if I want to change to other ways, like let's say A is here, B, C, D, E, F. Okay, it can be anti-clockwise or clockwise, or it can be anywhere. Okay, so the answer is n minus 1 whole thing factorial. So the n is 6, so it will be 6 minus 1 whole thing factorial, which is 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. You can also use the calculator to find 5 factorial. Okay, and the answer is 120 ways. That's the answer. Okay, now let's learn about permutation for identical objects in a circle. What type of identical objects that normally comes up in exam? Okay, identical is like beads or gemstone. Okay, when you see these two words, you know that you're going to use the formula, this formula. Okay, so let's look at this. For n identical objects in a circle, the permutations is given by n minus 1 whole thing factorial over 2. Okay, memorize this formula by heart. For example, the arrangement of objects in a circular bracelet or necklace do not involve clockwise or anti-clockwise directions because both are the same, which means that if it's clockwise or anti-clockwise, it doesn't matter. Okay, so we have to memorize the formula n minus 1 whole thing factorial over 2 if it involves identical objects in a circle, like beads or gemstone. Let's look at this example. Find the number of ways to assemble 12 beads of different colors to form a toy necklace. So the keywords here are beads and toy necklace, and the n is equal to 12. Okay, so this question is related to identical objects in the circle because it has beads and has a necklace. So these are the two keywords that we have to find in the question. Okay, so we're going to use the formula n minus 1 whole thing factorial over 2. And n is 12, so 12 minus 1 whole thing factorial over 2, which means it's 11 factorial over 2, and is equals to, okay, press the calculator, you will get 19,958,400 ways. And this is the answer. Let's look at self-exercise 4.2 question 1a. Without using a calculator, find the value of each of the following. Okay, let's solve for a. 8 factorial over 5 factorial will be 8 times 7 times 6 times 5 factorial. Okay, why we stop at 5 factorial? Because we can cancel off with the 5 factorial at the bottom. So 5 factorial and 5 factorial we can cancel. So the answer is 8 times 7 times 6, which is equals to 336. And this is the answer for A. Now let's solve for B. 8 factorial minus 6 factorial over 6 factorial. Okay, so the top I'm going to change to 8 times 7 times 6 factorial, and then I minus 6 factorial over 6 factorial. So we can factorize the 6 factorial out. So 8 times 7 is 56 minus 1 over 6 factorial. And then we can cancel off the 6 factorial top and bottom. So the answer is 55. Okay, now let's solve for C. 4 factorial over 2 factorial times 2 factorial. So 4 times 3 times 2 factorial. We stop here because we can cancel off with the 2 factorial top and bottom. So 4 times 3 is 12. Then 2 factorial is 2 times 1. So 12 divided by 2 is equals to 6. And this is the answer. Now let's solve for D. 7 factorial times 5 factorial over 4 factorial times 3 factorial. Okay, so we're going to write down 7 times 6 times 5 times 4 factorial. And then the 5 factorial we change to 5 times 4 times 3 factorial. Then over 4 factorial times 3 factorial. So we can cancel off 4 factorial top and bottom and 3 factorial top and bottom. Okay, so equals to, so 7 times 6 times 5 times 5 times 4, and the answer is 4,200. Let's look at question 2. Find the number of ways to arrange all the letters from the following words without repetition. So let's look at A, cert. So cert got how many letters? 1, 2, 3, and 4. So we're going to write n equals to 4. And the formula is n factorial, which means the number of ways is 4 factorial, which is equals to 24 ways. And this is the answer for A. Now let's solve for B. Locus. So locus, we're going to count how many letters? 1, 2, 3, 4, 5, which means n is equals to 5. Okay, and the number of ways is 5 factorial, which is equals to 120 ways. Now let's solve for C. Vector. So vector got how many letters? 1, 2, 3, 4, 5, 6, which means n is equals to 6. So number of ways is 6 factorial, which is equals to 720 ways. And next, D is permutation. So let's count how many letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Means n is equals to 9. And the number of ways is 9 factorial, which is equals to 362,880 ways. And this is the answer. Let's look at question number 3. What is the number of ways to arrange 7 customers to sit at a round table in a restaurant? So 7 will be your n, and round table. And customers is an unidentical object. Okay? So to find the number of ways, we're going to use the formula n minus 1 whole thing factorial. And n is 7, so 7 minus 1 whole thing factorial, which is 6 factorial, and is 720 ways. And this is the answer. Let's look at question number 4. Determine the number of ways to arrange 8 gemstones with different colors to form a chain. So the keywords here are gemstones and chain. So gemstones are considered as identical objects. So therefore, we're going to use the formula n minus 1 whole thing factorial over 2. Okay, and then we're going to substitute n equals to 8 into the formula. So equals to 8 minus 1 whole thing factorial over 2, which is equals to 7 factorial over 2, and is equals to 2,520 ways. And this is the answer.